Hello, this is Ms. DB, and today we're going to talk about Chapter 2, Section 2 on proportional reasoning. So we will be using proportions and rates and similarity and scale. This section reviews several topics from both algebra and geometry and kind of pulls them together as one review section. All right, so to start off, remember that a ratio is a comparison of two numbers by division, and a proportion is an equation that states that two ratios are equal. So you might write a ratio as 1 to 2, like a fraction, 1 to 2. You can write it like this, but in algebra we will almost always write it like a fraction. And then a proportion is when you say that two ratios are equal to each other. Like 1/2 is equal to 4/8, the ratio of 1 to 2 is equal to the ratio of 4 to 8. In a proportion, the cross products are equal. That means that 1 times 8 equals 2 times 4. Now we'll use that statement to solve proportions. When a proportion contains a variable, you can cross multiply to solve for the variable. And you'll be making an equation, and then you'll just solve the equation. Remember, we don't use this a whole lot, but you might have learned this maybe in geometry. The means, let's see, these two are the means. If you have A over B equals C over D, these are called the means. And these are called the extremes. So you may have learned that the product of the means equals the product of the extremes. You might have learned that that's how you say that a proportion cross products are equal. It's just another way of saying the same thing. To solve a proportion, you just say that the cross products are equal. So you're going to write an equation where 16 times 12 times 9 is equal to P times 24. And you can write those in either order. So instead of P times 24, you can write 24 times P. And 16 times 12.9 is, use your calculator, 206.4. Then we just solve by dividing by 24. So we find out that P is equal to 8.6. And you can check this by checking if 16 times 12.9 is equal to 8.6 times 24. And you should get the same thing because cross products are equal. To solve B, 14 times 132 will be equal to 88 times C. So cross products are equal, or you could say the product of the means is equal to the product of the extremes. And then we will divide and we'll find what C is equal to. On your worksheet, you'll have several of these problems to do. These are the ones from your worksheet. I don't think you'll have any trouble with any of them. It's just the product of the means equals the product of the extremes, or in other words, that the cross products are equal. So 9 times 9 is 81, and then you'll divide to solve. You will get decimal answers for several of these, maybe all of them. Now sometimes your proportion is going to be a little bit more complicated. In this example, we have, instead of just n as the numerator or the top number of our ratio, we have n plus 3. We're still going to solve the same way. We're still going to say that cross products are equal. So n plus 3 times 2 is equal to 5 times 7. And now we have to use the distributive property to simplify the left side of this equation, which we did in the last section, so no big deal. 2 times n plus 6 is equal to 35. Now we just have a two-step equation. We'll subtract 6 from both sides. 2n equals 29, divide by 2, and we get our answer. You can leave it as 29 over 2. You can change it to a decimal if you prefer. Now you have, these are at the end of your worksheet. I added 3 problems where you'll be using this to solve. And note that 15 is a little different. In 15, you don't have to use a distributive property. You'll just write the cross products are equal. So 12 times 3 is equal to 27 times 3r. There's no distributive property in this one. You'll just take 27 times 3 and then write the r after it. 6, 7, 8. 81r. And then we divide by 81 to finish, and we'd get r is equal to 36 divided by 81. So you can go ahead and use your calculator and get a decimal approximation of that. So just remember that you'll be using distributive property on these last few problems, or a couple of them anyway. So you'll do that first, and then you'll finish solving your equation. All right, percents can be solved using proportions because a percent means per 100. So 30% can be written as 30 over 100. So then we can use this little proportion, percent over 100 equals part over whole, and we can use that to solve. So in this word problem, we have a percent, and we have a total, that's the whole, and it looks like we're looking for a part. So a poll was taken one day before an election, and it showed that 22.5% of the voters planned to vote for a certain candidate. If 1,800 voters total participated in the poll, how many indicated that they planned to vote for the candidate? So let's set this up using a proportion. Percent over 100 equals part over whole. The whole was the people who they polled, which is the 1,800. The 22 point, or maybe that was the, let me read that question again. The voters, that was the voters, sorry. And we're looking for the part. We're looking for, so we put x there, and then we can solve this using cross products. So 22.5 times 1,800 equals 100 times x, or 40,500, and divide by 100 to get 405 would be those who voted for that candidate. You can also write an equation. So when you write an equation, you have to change the 22.5% to a decimal, which would be 0.225. And then once you have it as a decimal, you multiply it by the 1,800, which is the whole, the total, and that'll give you your part. So the decimal version of the percent times the total is equal to the percent. And you get the same answer either way. You get 405 either way. Either method is fine, whichever you prefer working with. You may have done both of these ways before. Maybe you've always just written an equation or always just written a proportion. In this example, it's 35%, and there are 434 students, and they play a sport. How many students does Clay High School have? This time they're giving you a part, and they're looking for the whole. So the proportion will be set up slightly different. You'll have to put the 434 in for the part, and we'll be looking for the whole, the x. Still would cross multiply to solve. It's still pretty easy to cross multiply, and we get that there's 1,240 students. To use a percent equation, again, use the 0.35 for the decimal, and we always multiply the percent times the whole, and in this case we don't know that, so that's where our x goes. So we would be dividing by 0.35 right here in order to find x, and we of course get the same answer, that there's 1,240 students. On your worksheet, you have 3 problems to do. You can use either method. You can use a percent, or you can use an equation. Each one of these is looking for the part. So in each one of these, x will be the part. That'll be the part you'll fill in. And these are the wholes. Should I use green here? This would be the whole. And then, of course, the percent is the one with the percent sign after it. So we've got the percent, the percent, the percent. Now remember, if you want to use the equation, you will take the percent as a decimal. Make sure you change it to a decimal. And then you will take that, so the percent times the whole. Let me color code here. Will be equal to the part, which is what we're looking for in each of these. So that'll be pretty simple. You can either use percents or the equation or the proportion. Here's an example of a word problem that's on your worksheet. We have 24% of the students attending the college are majoring in business. If there are 420 students at the college who are majoring in business, how many students are attending? We're looking for the whole. That's our unknown. Our part is the 420. And of course our percent is 24%, or use 0.24 if you are doing the equation method. All right, a little bit on rates. A rate is a ratio that involves two different units. So miles per hour, words per minute, dollars per gallon. Those are all rates that we use all the time. Here's an example, and I'm going to just kind of go through this. It says that Ryan ran 600 meters and counted 482 strides. How long is Ryan's stride in inches? Now they're telling us they're using a unit conversion that 1 meter is about 39.37 inches. There's a lot of tables on the internet, and there's one on your worksheet that have unit conversions. I would not have memorized 1 meter is equal to 39.37 inches, but it's a useful conversion in this case. So you would set up the ratio as meters per stride. 600 meters over 482 strides is equal to, I don't know how many meters over 1 stride, because that's what they're asking us. We'd use the cross product to find that 1.24 meters, this is one of Ryan's strides. And then they ask us to change that to inches. So if we write 39.37 inches over 1 meter, that's the conversion that was given in your problem, is the hint. So here's what we do. We take that Ryan had 1.24 meters over 1 stride length. We multiply that by this unit conversion. Now when you write your unit conversion, make sure that if you had your meters on the numerator, on the top of your ratio, then make sure that in the second one, when you multiply it by a unit rate, that you have that on the bottom, because then they will cancel. You can cancel units just like numbers. You've probably done this in science class before. Then we're able to take 1.24 times 39.37, and that's 49. And the only unit left on the top is inches. And on the bottom, the only unit, we only have 1 times 1, which is 1, and the only unit left is stride lengths. This is sometimes called dimensional analysis. You may have heard that phrase before. All right, let's try this one without me clicking through the answers here. All right, so Lewis ran 400 meters in 297 strides. Find his stride length in inches. So on the previous screen, we had the conversion factor of 39.37 inches is the same as 1 meter. Whoops, I went the wrong way, sorry. 39.37 inches is the same as 1 meter. Okay. We also know that we are trying to find, let me write it like this. We are trying to find how many meters are in one of his strides, and then we'll convert that to inches. So we cross multiply, and we get that 400 meters times 1 stride is equal to 297 strides times x meters. And then we would divide by 297 to find that 1 stride is equal to 1.35 meters. Okay, so we know that he has 1.35 meters in 1 stride. We also know this. We know that there is 39.37 inches in 1 meter. So now the meters would cancel, and you can multiply 1.35 times 39.37 to get our inches per stride, which is what we're looking for. So that's about 53 inches for 1 stride. So we're converting measurements here. Okay, here's another example. Now these are from the worksheet, but I changed the numbers. I changed the cities and things. So it's just like this on your worksheet, except different. All right, so also on your worksheet is this table that shows customary conversions so that you can use that as needed. I don't see meters to inches on here, but that's okay. All right, so Jenny drove from Los Angeles to Reading, 882 kilometers. She used 22 gallons of gas on the trip. Find the gas mileage in miles per gallon instead of kilometers per gallon. And there's a hint, which there is in problems that you need this, that you can use the conversion factor of 0.62 miles is equal to 1 kilometer. Now that conversion is not up here because it goes the other way. But this is a true conversion as well. It's just going the other way. I could add it up here if I wanted. 0.62 miles equals 1 kilometer. So you write your rate, 882 kilometers over 22 gallons. You start with that. Then you multiply it by something that will change my kilometers to miles. So let's write this as a rate. Do I want to write 0.62 miles over 1 kilometer, or do I want it written 1 kilometer over 0.62 miles? Which one of these would cancel the kilometers with the kilometers? So we want to cancel kilometers, so we're left with miles. So I want this one because then I have kilometers in the numerator and kilometers in the denominator, and they cancel, and I'm left with 882 times 0.62 divided by 22, and my units on the top would be miles, and the units on the bottom would be gallons. Now, I would still have to do the math, and I don't have my calculator on the screen right now, but I'd take 882 times 0.62, and then I would divide by 22, and I would get a number, something, miles per gallon. All right, here's another example. Amal drank 1.5 liters of water during her workout. Convert to fluid ounces. So I'm going to start with the 1.5 liters. Now this one isn't a rate, it's just going to be 1.5 liters. Now I'm going to multiply that by something that would change liters into ounces. So I go up on my chart, and I'm looking for liters and ounces. So here we go. Here's liters. I don't have a way to change from liters to ounces, but I can change from liters to milliliters, and then I can change milliliters to ounces. Well, that's what I'm going to do. I'm going to change liters to milliliters first. So I'm going to multiply this 1.5 liters by some form of 1 liter over 1,000 milliliters, or maybe I want to use 1,000 milliliters over 1 liter. Pick the one that would let me cancel liters on the top with liters on the bottom. I want liters on the bottom. I want this one. So I fill this in with 1,000 milliliters over 1 liter. Now I could do the math and get an answer, or I can just keep going. My units right now, let me cancel out my liters. My liters are gone. They'll cancel, and I'm left with milliliters. Now I want to change milliliters into ounces. I want to use this conversion. So I could either use 1 ounce over 29.57 milliliters. That's one rate. Or the other rate is take the reciprocal of that, 29.57 milliliters over 1 ounce. Pick the one that would leave me with milliliters in the denominator so that I can cancel, which is this one. So on the top, you're going to put 1 ounce. OZ is the abbreviation for ounce for some reason. And that would be over 29.57 milliliters. And then what happens is the milliliters cancels with the milliliters. And you're left with, this is in the numerator, so we're left with, let me erase this, 1.5, all my numbers here on the top, times 1,000 times 1 ounces is the units left on top, over, on the bottom we have 1 times 29.57. And our units left on the bottom, nothing left. So when you do the math, 1.5 times 1,000, and you divide that answer by 29.57, your answer will be in ounces, which is what we wanted. That's how you would do that problem. Similar figures. Now this should be a review from geometry. You should have had a whole chapter on similar figures. In similar figures, their angles are congruent and their sides are proportional. And we use the term scale factor when we compare their corresponding side lengths. Here's an example where you would be graphing in the coordinate plane. This is a little bit tricky to do in the online world because I'm not looking at your graph paper, but let's just go through an example. If you have a triangle XYZ with vertices 0, 0, -6, 9, and 0, 9, then we want a similar triangle to that with one vertex at 0, 3. Now, remember that the X names one of the vertices of the triangle, and it would correspond to, where's my other triangle? Oh, they use the same letters for X and X. And then Y goes with A and Z would go with B because they're in the same order. So we're going to finish graphing triangle XYZ. So we started it here. So this is our X. Y is at -6, 9. And Z is at 0, 9. So we'll finish drawing that triangle. Okay, so there's XYZ. Next, we're going to graph XAB for as much as we can. Okay, so what do we know? We know X is the same as X, so that's going to be the same. So part of my triangle is going to have the same vertex because they're both X. And I also know that B is at 0, 3. This is B. So we have some information already. I know that these two triangles are similar, so therefore I know that the height over the height is equal to the width over the width. I can set up that corresponding sides will be in the same proportion. The height of the little one is 1, 2, 3. The height of the big one is 9 because it goes all the way from 0 to 9. The width of the little one, I don't know that yet. I have to find that still. So I used X. The width of the big one, the purple one, goes all the way 1, 2, 3, 4, 5, 6. So now I set up this proportion and I solve it. So 3 times 6 is 18 and 9 times x is 9x. Divide by 9 and you get x is 2. Now we know that the width of the little one is 1, 2. So now I can put that this point was what, A? Now I can finish drawing my triangle. And the coordinates of A are -2, 3. This is just another picture of that graph. All right, what you'll be doing on the worksheet is more like these problems where you're going to have a situation and you'll be finding a missing part. A tree in front of Luca's house cast a 6-foot shadow at the same time as the house cast a 22-foot shadow. 2 O's. If a tree is 9 foot tall, how tall is the house? So this is called indirect measurement. You can use the shadow length at the same time in order to find the measurement of something that's too high to measure directly. You draw your two triangles. This is our tree right here, and it is 9 feet tall, and its shadow is 6. And then the house is right here, and its shadow is 22 feet. So we're going to set this up. So corresponding sides are in proportion. So you can go 9 to h equals 6 to 22, or you could go 22 over 6 equals h over 9. You could even go 9 over 6 equals h over 22. There's many ways to set up a true proportion here. our text here, this example decided to go shadow of the tree over the height of the tree. So that's going to be 6 over 9 equals 22 over h. That's a valid way to set up this proportion, but there's many others that would work correctly. Whichever way you do it, you should get the same answer. Otherwise, you made a mistake. So 33 feet high is the house. Here's another example. A 6-foot-tall climber casts a 20-foot-long shadow at the same time that a tree casts a 90-foot-long shadow. How tall is the tree? You're going to be drawing two triangles again. The 6-foot-tall casts a 20-foot shadow. The h-foot-tall tree casts a 90-foot shadow. It's a really tall tree. So in this one, they decided to do the shadow of the climber over the height of the climber is equal to the shadow of the tree over the height of the tree. And they solved this and found that the tree is 27 feet high. Here's an example from your homework. And I don't remember if I changed these values or if this is exactly your homework question. But we have a flag. And we're trying to figure out how tall that flag is if it casts a shadow that's 74 feet long at the same time that a building that is 40 feet tall, the school, casts a shadow that's 104 feet. So you're going to set up your proportion. You can either do the height of the flag over the shadow of the flag is equal to the height of the building over the shadow of the building, or you could do height of the flag over height of the building is equal to shadow of the flag over shadow of the building. That would also work. So you can try this different ways and you'll find that you get the same cross product set up and that you'll get the same answer either way. All right, so good luck. Let me know if you have any questions or have any problems on this assignment or would like to work together. Thank you very much and have a great day.